Okay, so like this is the problem that we have, that we are in the mountain and I want to come down. Okay, so and there is darkness everywhere. So like can you tell me how will we come down? Like if we are at this point, okay, and there is darkness everywhere, so how will we come? Any approach? Okay, so like let me tell you what we can do. One second, I'll change this a little bit. Suppose it is like this. Okay, suppose it is like this. Okay, and you are over here. Okay, now I told you that there is darkness everywhere,
Sir,
and yeah,
sir, could you allow Gayatri? She's
yeah, yeah,
waiting,
yeah, yeah,
sir.
yeah, yeah. I've allowed now. Guys, please be on time because like then a lot of time is wasted. No? Like we in the class at max at like 5. Okay, after that like you will be missing the things in the class. All right, so okay, and like what can I do over here? Yeah, Gayatri, you want to speak something? All right, so no problem. Okay, so what you can do over here, that you have some like okay, you have like you can use your foot. Okay, you can use your foot to see, like to feel the things that is forward and backward. So basically it's like this. Okay, you are over here. Okay, and what you will do, you will put your foot over here. Okay, first you will put over here, and then you will put your foot over here. Okay, then you will get to know, okay, I'm over here. Okay, when I put my foot in this direction, then what is happening, I'm going in the upward direction. And when I'm putting my foot in this direction, okay, in this right direction, then I'm going down. Okay, so this is left, this is right. Okay, so like what should I do in this case? Should I take the right step or should I take the left step?
To take the right.
Yeah, yeah, correct. Why we are taking the right step? Why not left?
Each of
Yes, I please tell.
yes, sir.
Mm-hmm.
To reach our destination point.
Mm-hmm. Yeah, we want to come down. No, we don't want to go up. Okay, so that's why we will not take the left step. We will take the right step. Okay, so like in the same way, okay, in the same way we do the things in okay, in our like machine learning models. Okay, the same thing we do in the machine learning model. Now like uh, like suppose like there are different terms that we need to understand. Okay, so first one is my like error term. Error term. Okay, now what happens, like suppose my input is okay 1 and my output is 4. Okay, what this means is that, okay, like this is my input, I want the output to be 4. Now I should multiply this input with some number so that I can get 4. Correct? Okay, so with which number should I multiply this so that I get 4?
4.
You know, we'll multiply it by 4. Now uh, suppose uh, how did you know that I have to multiply by 4? Okay, so the basically the equation is like this: input into, okay, we can consider this term as w, equal to output. Okay, and if I use the mathematics, then the W will be output divided by input. Okay, so basically it's like that. Now the thing is that I don't want to use, okay, I don't want to use this formula for finding the W. Okay, I don't want to use this formula. What I want to do, I will take some other approach of finding W. Okay, let's see what can be that approach. Like suppose, what will I do first, that I'll start with the W value of 0.01. Okay, the W value will be 0.01. Then I will find my uh, this this I'm calling it as prediction. Okay, prediction will be equal to input into W. So what is my input? Input is 1, W is 0.01. Okay, so my prediction would be 0.01. Okay, but what is my actual output? Actual output is 4. Okay, actual output is 4. Now what will I do? I'll find the error term. Okay, how far is my prediction from the output? Okay, I'll find this. So the formula for this is output minus prediction, okay, whole square. Okay, so like this is the formula for my error term, correct? Okay, so let's find the error. What is the error over here? Output is 4 and prediction is 0.01. So I'll square the term, so I'll get some number. So could you tell me what is this number? Could you find this on your calculator? So come on, please find this. What is this value coming out? Okay, so this value is coming out to be 15.9. Okay, so this value is coming out to be 15.9. Now this is my weight. Okay, and if I take this W, okay, this W I'm calling it as weight. Okay, just bear with this term. Okay, the weight. Okay, okay, so what we are doing, we will multiply the input by the weight. Okay, so using this weight I'm getting this much error. Okay, so how much error like in reality, how much error I want? What should be my ideal error value? Like, come on, what should be the ideal error value? What should be the error? Like here it is 15.9. What I actually want the error to be?
Need to be 0.
Yeah, we need it to be 0, no? So now I want to take this error to 0. So can you tell me what parameter I need to change so that the error goes down to 0? Which thing I need to change in the equation? Like what change I will do? In which?
Prediction.
Yeah, yeah, okay, I'll do the change in the prediction, and prediction is dependent on input and W. Okay, prediction is dependent on input and W. Now input is fixed. Okay, input is fixed. The changing part is W, that is weight. Okay, so what I will do, I will change the weight. I need to modify the weight in such a way that my error value reduces. Correct? Okay, I need to change the weight such that the error value like decreases. So can you tell me, like what should I do? Should I do some addition in the weights, or should I do some like minus, should I do some minus in the weight? Okay, now suppose I do the addition in weight. Okay, now my weight will, like suppose I added 0.05. Okay, then what I did, I subtracted 0.05. Okay, I did 0.05 and subtracted 0.05. Okay, now what will I do, I will again find the prediction. Okay, so prediction using this weight. Okay, so let's see what is the prediction now. 1 into 0.05, so this prediction will be 0.05. Okay, and prediction 1, and I'll find the second prediction, prediction 2. Okay, so this will be how much? Okay, what will be this? Okay, 0.01 minus 0.05. Okay, so 1 into negative 0.04. Okay, so this will be my 0.04. Okay, so these are my predictions now. Okay, sorry, the value of w, what was the w value? 0.01, no? Okay, so if I'll add, okay, 0.01 and this, then my weight will become 0.06. Okay, so this will be 0.06 and this will be negative 0.04. Okay, so these are my predictions now. Now what will I do? Using this prediction 1 and prediction 2, I'll find the error. Okay, so error 1 and error 2. So can you tell me the value of error 1 and error 2? What is the value? 4 minus 0.06 whole square, and the error 2 value is 4 minus 0.04 whole square. Now please tell what is the value of this? Okay, so this value is coming out to be 16.48, and this error value is coming out to be 4.04 into 4.04. Okay, 16.32. Okay, so now I have found two errors, E1 and E2. Okay, with respect to different weights. What was the weight value that I used over here for finding this E1? What was the weight I used?
Positive.
Yeah. So what was the final weight value that I got? It was 0.06, no? This was the weight value I used, and here I used, okay, this negative one I used, W minus. So what was W? W was 0.01 and okay, negative 0.04. Okay, so with these weight value I got this error, with this weight value I got this error. So which weight value should I choose? Which weight value should I choose over here now? This W1 or W2?
W2,
Why?
that is less than W1.
Hmm. 1 second. Have I calculated this correctly? 1 second. I'll just calculate this once again. 6 2 3 4 9 4. Okay, sorry. This I have calculated at wrong. This is 15.52. Okay, so now this is 16.32. So okay, so we need to select that weight, okay, which is giving me less error. Okay, so like this algorithm. Okay, now what will I do? Again I'll find the new weights. Okay, so my new weight now has become 0.06, and why I have chosen this weight? Because the error value is reduced because of this. Okay, now again I'll find the weight. Either I'll add to the weight something, or either I'll subtract something from my weight. Okay, so here we are using this 0.05, so again I'll use this 0.05 over here, and again I use this 0.05. Okay, so using these weights, okay, I will again find the error, and then again I'll choose that particular weight, okay, which is reducing my error value. Okay, so like this is the way we find the, okay, like value of these weights, okay, in machine learning. Now you must be thinking that like why we are not simply dividing. Okay, here you can easily see that W is equal to prediction divided by input. It's so simple, but why I am taking this long step? Okay, so why, like the answer to this is that, like in like real life data, okay, in real life data, okay, the relationship is not so simple. Okay, the relationship is not so simple as we have seen in this equation. It is not so simple. Okay, so it is like very complex, very complex. So we cannot reduce the error, we cannot reduce the error to zero. Okay, we cannot reduce the error to absolute zero, but what we can do, we can like minimize, we can minimize the error. Okay, we can minimize the error. That's the thing that we have in our hands. Okay, so in order to minimize the error, okay, then we will be using this approach that I have told you. Okay, so if I like tell you this approach, okay, in this term, okay, so this thing is known as, okay, this mountain that we are seeing, okay, this thing we will call it as our error. Okay, error. Okay, so what I want the error to be minimum. I want to minimize the error. Okay, and the value that we were adding, okay, to the weights, okay, that thing I'll call it as my step size. Okay, because like I can take one step in this direction, I can take another step in this direction. Okay, so how long step that I will take, okay, so this thing is known as my step size. Okay, so what was the step size that we were taking in this example? What was the step size? What was the like by how much value I was increasing or decreasing my weights in every iteration? Like
Yeah, it's 0.05.
0.05, no? So 0.05. Okay, I was increasing my, like this was my current weight. Okay, I increased my weight, okay, to some value, then I saw, okay, then I saw whether the error is reducing or not. Okay, first I'm increasing and then I'm decreasing. Okay, then what I'm doing, I'm checking these two values. Okay, like if you see over here, I took one step and calculated this value. I took another step, I calculated this value. Now I will check that whether this is high or this is high. Okay, so I'll choose the value which is low. Okay, so I'll go with the this particular weight. Okay, so okay, so the algorithm, like this algorithm that we have seen, okay, so this is known as hot and cold learning. Okay, so the algorithm that we have seen right now, this is known as hot and cold learning. Okay, so like what we want to do, we want to okay, finally reach the bottom. That means I want the error to be minimum. Okay, I want my error to be minimum, but like what should be my approach for coming down? Okay, so that is what like we will be, okay, studying. So one of the approach, okay, one of the approach in which we can minimize the error, that is known as hot and cold learning. Okay, so like let's see the code of this hot and cold learning, so that this thing will be more clear to you. Okay, so see, I have input as 1, output as 4. Okay, so I'll run this. So this is my input, this is my output. I choose my weight to be 0.01. Okay, and p output means that the predicted output. Okay, now I'll multiply input and the weight. Okay, and then I'll find the prediction what I have predicted. Now what will I do? I'll find the error. I have defined a function. Okay, I have defined a function. What it will do, it will find this uh, like squared error. Okay, the prediction that I did and the actual output. Okay, and I'll take the square of it and I'll return this error. Then I call this error function and I pass this prediction. Okay, this prediction and the output that I have. Please note that the actual formula that I earlier told you, that was the actual minus the predicted output. Okay, so that is the thing. Okay, now what will I do? I'll choose my step size. Okay, like how much, okay, I want to move forward or how much I want to move backward. Okay, so that's that thing I'll choose. So what I did, I found this forward. Okay, I found, like I multiplied input with the forwards, like I increase the weight, okay, by this step size. Okay, and then I found the prediction. Okay, so this prediction I'm calling it as forward prediction, and this prediction is known as backward prediction. Okay, now I did this. Now when, okay, so I'll pass this forward and output, okay, to this error function. Okay, so what is this forward telling? Forward is telling that if I increase my weight by a step size, okay, so what will be my output? Okay, and this error will find the error. Okay, error term. So like if I moved forward, then the error came out to be 13.6. Let's see, if we move backward, then what will be my error? Okay, so if I move backward, my error is 18. Okay, so in which direction should I move? Error in the forward direction is 13, error in the backward direction
We move
is
to forward.
18. We have to move forward. Okay, and how will we move forward? How will we move forward?
Now we will add that to that weight.
We'll increase the weight by a step size. Okay, so we increase the weights by the step size, and then again I found the output. Okay, I found the output. So this is my output now. All right, now I'll run this again. Okay, now what I have done, that the weight have like increased by the step size again. Okay, so like here you can see that I increase the weights. Okay, and like I'll run this. Okay, I've run this. Now I'll see that if I move in the forward direction, like this is my error, and if I move in the backward direction, okay, why is this coming like this? 1 second, I'll run this again. Okay, okay, so I have increased my weight, and now I will run this. Okay, so when I moved again in the forward direction, the error, okay, is minimized. Okay, error is less, so that's why I have to again increase my weight. Okay, so I increased my weight. I again like find the forward and backward, and then again I found some values. That is, when I moved in the forward direction, my error is 9.5. Okay, when I moved in the backward direction, it is like this. Now, so that means I'll again increase my weight, because when I am moving in the forward direction, then my you can see that the error is reducing. Okay, so in this way only we will be finding that particular weight, okay, for which my error is minimized. All right, so like I have written this simple code where what I have done, that I have used this input and output. Okay, so this is the output that I want and this is the input, and this is my weight, and I'll use the step size as 1 over here. Okay, and like just like this is also one term that we have, that is the iterations. Okay, so what I will do, I will first calculate the mean square error with the current weight that I took. Okay, I'll find the error, and I'm naming that error as MSE. Okay, now what am I doing, I'm finding the forward. Okay, I'm finding the output when I'm moving the forward direction. I'm finding the output when I'm moving in the backward direction. Then I'm finding the forward error, I'm finding the backward error. Okay, so then what will I check? I will check if forward error is greater than the backward error. Then what should we do? If forward error is greater than the backward error, should we move in the forward direction or backward direction?
Moving backward.
Yeah, we have to move backward. That means we have to reduce our weight. Okay, so that's why I moved in the backward direction. Okay, and like my mean square error will be the error that I got in the backward direction. Otherwise what will happen, I will increase my weight and the mean square error will be the forward error. Okay, so what will I do, what will happen in every iteration, my this error, that is MSE, okay, will keep on reducing. Okay, this MSE will keep on reducing. Okay, and what am I doing, like when my this MSE value is less than 0.01, okay, then I'm stopping my iteration. Okay, so let's run this code. Okay, so okay, so like what is this first value that I have over here? Okay, so this is the error. Okay, okay, so I will call it as initial error. Okay, this is my initial error that has occurred. Now what will I do? Okay, this is my initial error, and like this is the iteration that I'm in. Okay, how many times I have like okay, so this is my iteration, and this is my actual output. What is this output over here? uh, 1 second, I'm okay, let me change this. Okay, okay, so let me change this, like suppose the input is 2 and the output that I want is 10. Okay, so you can see that okay, so like this is the error that I'm getting. Initial error is 99. Okay, then in the first iteration the error reduced to 63, then it went to 35. Okay, so in the fifth iteration what happened, the error came out to be very less, and you can see but why is this like this input into this thing I'm doing wrong? Okay, here I have to multiply by weight. Okay, so you can see that this is the like predicted output and this is my actual output. Okay, so like what has happened over here, that when I ran this thing 5 times, okay, I was able to like okay, reduce my error. Now suppose I increase this output value to 20. Now you can see that I'm able to find the actual value in 10 iterations. Okay, 10 iterations. Now if the output value is 30, then it is taking more iterations. Okay, okay, then it is taking more iterations. Now like actually like this is the problem with this algorithm. Okay, what is happening over here, that see, it is like this. Okay, it is like this. Okay, so when I'm here, okay, I'm taking a fixed step. Okay, I'm taking a fixed step. One approach is this: I'll take the fixed step and I'll come like this. Okay, one approach is this. Okay, now I have another approach. Okay, now I have another approach. In that, what I'm doing, that okay, just consider that these two curves are same. Okay, instead of taking a single step, now I will see that if now I'll see that here, okay, uh, okay, the slope is very high. Okay, the slope is very high, that means I can move forward. Okay, that I can move forward, like I can take a larger step over here. Okay, because the slope is high over here, that is the meaning is like this, that if the slope is high, then take a higher step. Okay, and if the slope is less, okay, then take a smaller step. Okay, so we can see that the slope is high, then I'll take a higher step. Slope is high, I'll take a higher step. Slope is high, I'll take a higher step. Now what will I do? The slope has reduced over here. Now I will take a smaller step. Okay, okay, so like this is also one of the approach in which we can reduce the error that we have. Okay, so this is my error term. Okay, this is my error, and these are my weights. With respect to the weights, what are the error values? Okay, so like this is one of the approach. If slope is more, okay, if slope is more, then take a bigger step. If slope is more, take a bigger step. Okay, and when the slope gets down, take the smaller step. Okay, okay, so are you able to understand the difference between these two algorithms? Okay, so this one is hot and cold. This one is hot and cold learning. Okay, this is hot and cold learning, and this is known as gradient descent. Gradient descent learning. Are you able to understand that like why this is a better approach? Can you tell me why this approach is better, this gradient descent? Yeah, please tell, anyone, please tell, why is this approach better?
So in this
Mm-hmm.
gradient descent learning,
Mm-hmm.
uh, we choose very less points that based on the slope,
Mm-hmm. Mm-hmm.
we choose very less errors.
Mm-hmm.
Yeah. Yeah.
Less error, like this will also like finally come to the minimized error, no? This will
Yeah,
also
but
come to uh-huh.
it will take more time that each error calculate.
If we talk about the steps, okay, that
Hmm.
this person has moved, that will be very large. And if we compare this to this one, okay, the number of steps that it has taken is less. Okay, so that's why this gradient descent is a uh, like optimization. Okay, optimization over this algorithm that is known as hot and cold learning. Okay, so like how do we like approach in this gradient descent algorithm? Okay, so what we do, that first we will find a slope. Okay, first we'll find a slope. Let's see that what is my equation. Okay, what is my error term? Error is, okay, error is output, like I'll just simplify this. Okay, I'll write actual, okay, actual value that is there minus, okay, here I'm using the predicted value. Okay, so in predicted I'll write, how am I calculating the predicted value? I'm multiplying the input by a value that I'm calling it as weight. Okay, sorry for that, I'll use that. Okay, and then I'm squaring this term. Okay, so this is my error term. Now suppose I want to find the slope. Okay, I want to find this slope. Now suppose, okay, let's take another example, like okay, I can be over here also, and okay, two possibilities are there. I can be here also, I can be here also. If I'm here, should I move in the left direction or right direction? If I'm over here, please tell, should I move in the left direction
Left,
or
left,
right direction? Huh.
left.
Should
It
move
will
in the
left.
left direction, and if I'm over here, then I should move in the right direction. Why? Because I want to come to this point, okay, where the error is minimum. Okay, now like you know that okay, slope, okay, like you must have seen the term slope. Okay, so basically slope is like this. If it is like this, okay, then the value of slope will be high over here. Okay, and if it is like this, okay, then the value of slope will be less over here. Okay, now what happens is that if, okay, if, okay, if we calculate the slope at this point, okay, so will this slope value be positive or negative? If I calculate the slope at this point, then whether will the slope be positive or negative? And if I calculate the slope in this direction, okay, in this direction, then tell whether it will be positive or negative. Yeah, any guess? Like first tell me what is the formula for slope? What is the formula for slope in terms of theta? Like this is my theta, na? What is the formula for slope? Okay, so the formula for slope is tan theta. Okay, this is the formula for slope, and theta is the like angle. Okay, theta is the angle that this tangent, okay, that this tangent is making with the x-axis. Okay, so can you tell me that the value of tan theta, like if we go from 0 to 90 degree, the value of tan theta is positive or negative from 0 to 90 degree? Okay, if we go from 0 to 90 degree, the value of tan theta will be positive. Okay, and if we move like greater than 90 to 180 degree, okay, then the value of tan theta will be negative over here. Okay, and this is my weight. Okay, this is my weight. Okay, this is my weight. Okay, this axis is my weight. Now you know, okay, in this case, now tell, will the slope value be negative or positive? Like, is this theta greater than 90 or less than 90? Just tell this.
Less than 90.
This is less than 90 na? So that means my slope value will be positive, not negative. Okay, slope value will be positive. But what is happening to my weight? Should I reduce my weight or should I increase my weight? You told me that we have to move in the left direction. If we are moving in the left direction, then is weight increasing or decreasing? Yeah, please tell, is weight increasing or decreasing? See, the axis is like this, no? It starts from 0 and it goes like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so in x, like why this x-axis goes like this? Now tell whether the weight is increasing or decreasing.
Decreasing.
Eh? Decreasing
It
or
will decrease.
decreasing? Now you can see that. Okay, so you can see, like suppose here the weight was 7, now here the weight is 6. Okay, so my weight is decreasing. Okay, my slope is positive but my weight is decreasing. So what should I do? Should I write like this? Should I write like this? Weight is equal to weight plus slope. Should I write like this? Is this the correct equation? See, here what has happened, if the slope is positive, that means I need to move in the like this direction. I need to reduce something from my weight, correct? And if I'm in this direction, what will happen? That my slope, this theta will be greater than 90 and my
The
tan theta value will be negative.
weight will increase.
Here weight will increase. But if I write the equation like this, then what will happen to the weight? Okay, now suppose slope value is positive. Okay, where the slope value is positive, in this part slope value is positive. So if I write the equation like this, then what will happen? W equal to W plus something. Okay, so what will happen? Weight will not decrease, it will increase. Okay, okay, so that's why what we need to do, we need to use this minus sign over here. Okay, if I use the minus sign, then what will happen, that like see, here the slope is positive, that means I need to go in the, okay, I need to reduce the weight, so that's why I use this negative term. Okay, negative slope. Okay, minus slope. Now suppose the slope is negative, I need to move in the positive direction. Okay, if my slope is negative, then I need to move in the positive direction. So when slope will be negative, then negative negative will become positive, and okay, so finally the weight value will increase. Okay, so like this is the formula that we use in gradient descent, W equal to W minus slope. Okay, so are you able to understand that why we are using minus slope, not plus slope? Please tell, is this thing clear?
Yeah, it's clear, sir.
It's clear. What about others? Like, is this thing clear to you, or like you have any doubt? Then you can ask me. Like, it is a very straightforward concept. There is nothing much, but like you need to understand this thing. Why I'm like when the slope is positive, when the slope will be negative. Okay. So this is the formula that I will use. Okay, for updating the weights. Okay. Uh, Now, okay, so let's see. Okay, how will we find the slope? Okay, how will we find the slope? Okay, so my prediction, okay, prediction value is input into, okay, like suppose I'm writing the prediction as p and input as x into w I'm writing. Okay, and my output, okay, my actual output is like y I'm using
It's
over
not
here.
showing.
1 second, I'll
Please.
go. Yeah, yeah, yeah. Now I've shown. Okay, so the error term will be y minus x into w whole square. Okay, so this will be my error term. Now I want to find the slope. Okay, now I want to find the slope at a particular point. Suppose I want to find a slope at this point. Okay, so can you tell me what will be the slope at a particular w value? At a particular w value, what will be my slope? At a particular w value, what will be my slope? Okay, so the slope, okay, the slope will be like this, de by del w. Okay, this will be my slope value. Like you must have studied, no? If y equal to x square, okay, y equal to x square, then dy by dx is the slope value, okay, at that uh, a particular, okay, x. So in the same way, at that particular w, Okay, what will be my slope? This will be my slope. Now can you tell me what will be the differentiation of this term with respect to w? Okay, so this is you can consider it as differentiation. Okay, although I have written the partial derivative over here, but you can consider it as like full derivative. Now tell, what will be the
2,
derivative?
2 into y
Uh-huh.
minus x into
Mm-hmm.
w.
And that's it. We'll also look at this w now.
P by dw of
We will also differentiate the inner term now. So what will be the differentiation of inner term? What will be the differentiation? Come on, like this term, what will be the differentiation of inner term with respect to w? Okay, so this will be constant. Okay, this will become 0 and this will come out to be negative x. Correct? This will come out to be negative x. So okay, so this is the formula for my slope. All right, now I told you that the formula for my w, okay, the w will be w minus slope. Okay, the formula will be w equal to w minus slope. Now it will be del e by del w. Okay, and w will be equal to w minus, okay, 2 into, okay, y minus x into w into minus x. Okay, so this will be my equation which I will use for updating my weights. Okay, uh, okay, when I'm okay, this thing is like true for this only. Okay, if my prediction is x into w. Okay, if my prediction is only x into w. Okay, so this will be my like weight update value equation that I will use. Okay, so now let's see like how we do this programmatically. Okay, I have defined a function known as prediction. Okay, what it is doing, it is multiplying input, okay, input into weight. Okay, input into weight, and I have the update equation. Okay, update w, okay, increase the weight, where what I have done, that I have used these terms weight, slope, learning rate. Just forget this term learning rate now, right now. Okay, I'll use this term. Okay, so as you can see that what is the like this value, what is this value that we are using? It is slope into input. Sorry, no, it's not slope into input, it will be slope only. Sorry, 1 second. Yeah, this will not be this. Okay, so what you have written in your okay, what you have seen that the weight equation is like this. Okay, weight equal to weight minus slope, है ना? Weight equal to weight minus slope. So same thing I have written over here. The update will be like this: weight equal to weight minus slope. Just forget this learning rate over here right now. Okay, this thing I have set it to 1. Okay, so it will not play any effect in this. Okay, so I have written the term as it is. Okay, weight equal to weight minus slope, and I have defined a function which is known as error, which is finding the squared error. Okay, so this thing it is finding. Now what I'm doing is I'm running this loop for 5 times. Okay, first I'm finding the predictions. Okay, so prediction I'm finding by calling this prediction function. Okay, so that is input into weight. So like, this is pretty straightforward. Then what I'm doing, the prediction that I have found and the actual output that I have, okay, I'm passing it to the error function. So error function will find the squared value. Okay, and now what I'm doing, I'm finding the slope. Okay, so this will be my slope. So So just see, okay, I told you, the slope value will be this, w equal to w minus, like what will be my slope value? See, del de by dw, what is the value of de by dw? Okay, so 2 into y minus x into w. Okay, 2 into y means actual output. Okay, y minus x into w. What is x into w? Okay, x into w is the prediction. Okay, the prediction that I have found. Okay, and then I'm multiplying it by input. Okay, you can see that we are multiplying it by x, and what I have done, I have taken this negative sign to the front. Okay, so that's why I have multiplied it by -2. Okay, okay, so this will be my slope value. Okay, now I will like update my weight. Okay, so I will update my weight. So what I'm doing over here, weight equal to weight minus slope. Okay, just ignore this learning rate for right now, I told you. Okay, so what will I do, I will run this, okay, code, and we'll see that what is happening. Okay, so I ran this code. uh, 1 second, I'll run this. Okay, so like this is the, 1 second, I'll, 1 second, let me change this to some other value. Just give me some time. Why it is not running properly? Actually, there's some problem in this. Actually, what should happen, that the error should reduce by every iteration, but it is not reducing. I don't know what is the problem over here. uh, just give me 1 second. 0.02. Why it is making like this? Just give me some time. I'll just fix it. Okay, there is something wrong that I have done over here. uh, what I should do, I should okay, I should just give me 1 second. Okay, I'll just okay, I'll, what I need to do, okay, I need to, like, I'm making an array that is wa. What it will do, it will store the value of every weight. Okay, every weight of every iteration that is happening. Okay, so wa dot append the weight that is over there. Okay, then what will I do, I will plot. Okay, I'll plot this term, that is input into the weight. 1 second. Yeah, here I need to give this okay, w1 I'm using. That is w1, and e1 dot append e. Okay, so error I'm storing in e. So let's say that the error is like high. Okay, the error is high. One dot append e, and error is t1 into input comma output is correct. t1 comma area. Okay, I don't know what is the problem over here, like why this graph is not coming correctly. But see, like what is happening over here, just try to observe this. Okay, so in my first iteration, what is happening, that prediction is 0.1, but the actual prediction that I want is 3. Okay, so you can see that I have this error term. Okay, now what will happen in the second iteration? Okay, what will happen in second iteration, the prediction is moving towards the actual output value that is there. Okay, so it will move towards the 3. Okay, and my error will reduce. So you can see that it was minus zero point 0.1, now it has moved in the positive direction. Now again, okay, in the next iteration it will move much more in the positive direction and my error will reduce. Okay, so you can see that error is reducing with every iteration. Now suppose I increase my iteration to 100. Now let's see what happens. So you can see that okay, that my error is reducing, okay, continuously. My error is reducing continuously and my final output, that is very close to my actual output that I have, that is 3. Okay, so you can see, uh, and suppose if we use this, just give me 1 second, like learning rate, I'm using it as 1. Then what is happening? Okay, the learning rate is creating some problem over here. Okay, I'm making it as 0.9. Okay, this value is working fine. Okay, so see, like these are the things that are happening over here. With every iteration my error is reducing. Okay, first it was 9632100. Okay, uh, now I'll tell you that what is this learning rate doing. Okay, the learning rate is actually like see, it is we are multiplying this slope value by some term. Okay, so like if I want that, uh, okay, the step that I will take should be more. Okay, then I will okay, then I will increase my learning rate. Okay, and if I want that, see, basically it's like that. Okay, see, basically it's like this. Okay, this is my error function. Okay, like if I'm using the update equation like this, w equal to w minus slope. Okay, so what was happening, that this was coming down as per the slope value. Okay, although the slope will be high, that's correct. Okay, slope will be high, but what we need to do, that sometimes slope can be very high. Okay, the slope can be very high, so that what will happen, that this value will like not come over here, it can jump here also. Okay, it has increased the weight so much that it has come to this part, but I don't want this. Okay, so that's why what we need to do, we need to reduce this step size. Okay, so how will we reduce? We will reduce the slope value. And how will we reduce the slope value? By multiplying some value which is less than 1. Okay, so I will multiply with value less than 1, that is zero point 0.9 or zero point 0.8. Okay, so like what is the problem with slope? The problem with slope is that if slope is very high, then like this comes down very quickly. Okay, the step becomes very large and I need to reduce that step size. So for reducing that step size, I will be using a term known as a learning rate. Okay, so like I'll show you. Okay, now suppose I reduce my learning rate. Okay, I will reduce my learning rate to 0.01. Okay, now we will see that what will be my error. See, see, the error is very high. Okay, the error term is reducing very slowly. Okay, if the learning rate is very low. Okay, if my learning rate is very low, the error is reducing very slowly. Okay, and if I increase my learning rate, okay, so now suppose I make it as zero point 0.1. Now see, the error is coming, okay, going down very quickly. Okay, now suppose I increase my learning rate to be like greater than 1, 1.2, suppose I'll do. Okay, so you can see that instead of increasing, the error is increasing now. Okay, so like this is creating some problem for us. So that's why what we need to do, that we need to reduce the learning rate. Okay, it should be like basically learning rate value should be in this range only. Okay, zero point 0.1 or like 0.01. Okay, so this should be our ideal learning rate. Okay, so you can see that like if we take learning rate to be zero point 0.1, then it is, okay, it is like going very near to the actual value. Okay, okay, pretty fast. So if I want to like come more close to my actual prediction, I will make this as, okay, I will increase the number of iterations. Then you can see that the final output will be very close to my actual output. Okay, so this is my actual output is 3 over here. Okay, all right, so like this is the thing that I wanted to tell you in this session. So when I was telling about that linear regression, okay, I was telling about the linear regression, then like I told you that there was a term that was known as max iter. Okay, so max iter, what it was referring to, it was referring to the number of iterations that will happen, okay, in the gradient descent algorithm that we are using. Okay, so that was the meaning of that. I don't know what was the code that I was using there. I have specified the maximum iterations. Once again, I like, okay, I was using that in logistic regression. Okay, I was using that in logistic regression. I'll show you, or I'll show you this one also. Okay, so in this gradient descent, like the meaning of this, okay, with every iteration my error should reduce. Okay, with every iteration my errors should reduce. So if the number of iterations are high, okay, if they are very large, okay, so what will happen, like here I have specified 20. If I specify it as 50, okay, then what will happen, it will come more closer to the actual value. If I make it as 100, if I make it as 100, then see, it will come more closer. These 9999 values are actually increasing, and the error term, okay, see, the error is e to the power minus 11, e to the power minus 15. So error is continuously decreasing. Okay, so let me show you where I have used this. If I'll show you that in logistic regression we specified a term known as max iter. Okay, this max iter. Okay, this max iter means this value that I'm using over here, for how many iterations I'm running my gradient descent algorithm. Okay, yeah, so like that was it in like this session. Okay, so just make yourself familiar with the terms that I told you. Okay, that is this hot and cold learning, gradient descent. Okay, uh, like this error term. Okay, error term. All right, like we have seen that if, okay, my function is the error term, Okay, if my function is the error term, then what happens that I need to reduce the error. Okay, my goal is to reduce the error, but like things can be reverse also. Okay, things can be reverse also sometimes. If I talk in terms of accuracy, then my goal is to increase the accuracy. Okay, so what will I do? Okay, I will move in the reverse direction. Whatever gradient descent was telling me, I will move in the reverse direction. Okay, so that thing is known as like gradient ascent algorithm. Gradient ascent. Okay, in gradient descent we move down. Okay, but in gradient ascent we move up. Okay, so that like this curve that we have over here is now of accuracy. Earlier it was of error, now it is of accuracy. So now I need to like reverse the things whatever I am doing. Okay, all right, so that was it in this gradient descent algorithm. uh, like, do you have any question that you want to ask? uh, is this algorithm clear to you, or like you may think that like this algorithm is like a little bit like we are doing so many steps in this, but just try to do this thing by your own, then like you will be able to understand like why this is actually working. Okay, and like this is the basis for all the machine learning algorithm. You should definitely learn this algorithm, that is gradient descent. Okay, so same algorithm is used in on all machine learning models. The simple equation that I told you, na, w weight equal to weight minus slope, same equation is used in all the machine learning algorithms. So I need you to be like familiarize yourself with this algorithm. Okay, just practice this algorithm by your own. All right. So, all right, students. So that would be it in this session. I hope you like gain something out of this session, and we'll be meeting tomorrow. Okay. So till then, bye bye, everyone. Okay. So bye bye.